Hello everyone, we are group 23. Our topic is email encryption. In this presentation, we will talk about why we need email encryption, how does that work, and some detail of two protocols that are widely used for email encryption. The main purpose of email encryption is to protect the content in the message being acquired by other entities rather than the right recipients. We want to protect the privacy and detecting message modification from third parties. Then how does that work? Basically, we have two methods in general: transport layer encryption and end-to-end encryption. For transport layer encryption, if Alice wants to send message to Bob, at the beginning, Alice and the server will have shared key KA. By using this KA, Alice will encrypt the message and send it to the server. After decryption by the server will use another shared key KB that Bob has, encrypt and send it to the Bob. Then Bob will see the message. On the other hand, end-to-end encryption allows only the communicating user to transfer information between each other. The plain text gets encrypted at the users and decrypted in the other hand. These are two methods in general. Then we will talk about the detail of two email encryption protocols, S-MIME and PGP.
In this section, I will talk about S-MIME. First, let me introduce the workflow of S-MIME. A sender creates a plain text message. A hash code of the message is created by using SHE-256 algorithm, which is 256-bit. This message digest is encrypted with RSA with the sender's private key and appends signature to the message. Then the plain text message and text signature are encrypted as a single block using symmetric encryption, which is the AES 128 algorithm combined with the Cipher blockchain with a one-time security key generated by the sender. The security key is encrypted using the RSA with the receiver's public key and included in the message. For the decryption process, after the receiver receives the encrypted message, the receiver uses RSA with the sender's private key to decrypt and recover the secret key created by sender. Then sender uses this key to decrypt the message digested by using AES 128 algorithm and Cipher blockchain. The receiver generates a new message digest for the message and compares it with the decrypted hash code. If the two matches, the message is accepted as authentic. Next, I will introduce the security service of S-MIME. The authentication is provided by means of a digital signature. The combination of RSA and SHE-256 provides an effective digital signature. Because of the strength of RSA, the recipient is assured that only the processor of the matching private key can generate the signature. Because of the strength of SHA-256, the recipient is assured that no one else could generate a new message that matches the hash code, and hence the signature of the original message. S-MIME provides confidentiality by encrypting message. Most commonly, AES with a 128-bit key is used. With the Cipher blockchain mode, the key itself is also encrypted, typically with RSA. For compatibility, many electronic mail systems only permit the use of blocks consisting of ASIC text. To accommodate this restriction, S-MIME provides the service of converting the raw 8-bit binary stream to a stream of printable ASIC characters. There are some limitations of S-MIME. S-MIME uses 509 certificates that are issued by certificate authorities. Before using it, each user needs to obtain an individual certificate from an in-house certificate authority or by buying one. The costs involved with either creating certificate authority or buying a certificate for each sender may well be prohibitive and the process overly complex. It also adds complexity to the recipient experience. The end-to-end encryption involves preclude email search, so users can't search through historical emails, except for subject line and attachment names. Then, in the next section, Michelle will talk about PGP.
Designed by Phil Zimmermann, Pretty Good Privacy is another email encryption scheme. The workflow of PGP consists of 4 major steps for sender: digital signature, message encryption, compression and conversion, and finally segmentation. Similar to S-MIME, it provides 2 essential services for email security: confidentiality and authentication. PGP protects the confidentiality of emails by encrypting the message and the session key. The session key is generated for each email and may not be reused. It provides authentication service by prepending the digital signature to the message. Unlike the use of certificate chain in S-MIME, Web of Trust is used for public key authentication. The idea behind Web of Trust is simply by making trust transitive. The users in the network are allowed to sign the public key of other users who they trust. For example, Bob declares that the public key KB is his public key. If Alice is sure that it is Bob's public key, then Alice may want to sign the key KB. In this case, if another user, Carol, wants to get Bob's public key, she may believe that KB is indeed the public key of Bob, since she trusts Alice. For each node, there are 2 keyrings: the private keyring and the public keyring. The private keyring stores the user's private keys. It is possible and legal for a user to have multiple private keys. The public keyring stores other users' public keys that are known to the node. PGP established key identity authentication utilizing the trust level associated with each public key in the user's public keyring. 3 fields are associated with each public key that a user stores. The first one is the owner trust field, where the owner of the keyring specifies the level of trust for this public key owner. As the users are allowed to sign other people's public keys, the owner may acquire other users' signature for a single public key in the ring. And the signature trust field specifies the level of trust the owner gives to that signature. And we also have key legitimacy field. Based on the signature trust field associated with the public key, PGP calculates a key legitimacy value for that key. As an example, the public keyring can be illustrated as a tree. Each node represents the public keyring. Each node represents the public key of a user, and the node with label U refers to the owner of the keyring. The shading of each node indicates the level of trust you give to the signature from the user. Node A has 2 arrows pointing to it, meaning that user A has signed the public key of user G and H. It can be noticed that PGP considers the public key of user H legitimate, since both A and B, who you partially trust, have signed the key. In the report, we will also analyze the pros and cons of the use of trust, and to compare it to certificates in S-MIME in terms of the suitability in different contexts. And here are the references we've used. Thanks for watching our presentation.